So we understand from the definition of a vector that geometrically a vector is some sort of directed line segment, right? Because my vector is defined as direction from theta as well as magnitude, which would be length. That's a geometric representation. Now, how do I represent something algebraically? Well, normally when we represent something on, let's say, a Cartesian coordinate plane, right, where I have an x and a y axis, we have 2 points. And in this case, we would say then that the vector u would be equal to the ordered pair A, comma B. So how do I find either of these two components? And that's what we're looking at in this particular lecture. So the first thing that we want to look at is talking about if I'm given an ordered pair AB, and notice that these ordered pairs are written in some sort of like bracketed, kind of, they're not parentheses, but anyway, if I'm given the ordered pair, can I then find what the magnitude or length of the vector is, as well as the angle associated with that vector? Because remember, vectors are direction and magnitude. So this is how we're going to go about using basically Pythagorean's theorem and also inverse tangent to be able to come up with these two values. So there's two ways for us to think of this, or two ways for us to do it. The first part we're going to work over here on the left-hand side is figuring out to answer this question algebraically. So if I am given that I have the vector u is equal to 3 comma negative 2, well, what is the magnitude then of u? So our formula above told us that u comes from the square root of my a squared term, which would be 3 squared, plus my b term squared, negative 2 squared. So in other words, 3 squared, which would be 9, plus 4 gives me a magnitude for u of the square root of 13. Now the other component to my vector needs to be its direction. The direction comes from the inverse tangent of my b term over the a term. So inverse tangent of negative 2/3. On this, I'm going to have to figure that out using my calculator. So when I put the inverse tangent of negative 2/3 into my calculator, I end up with a negative angle measurement for tangent. Now, a couple of things that you need to make sure you're doing at home. First of all, since we're talking about the angle theta, that is a clue that I need to be in degree mode as opposed to radian mode. So make sure that your calculator is set to degree mode since we're talking about theta. The second thing I need to understand is when I take the inverse tangent, on my calculator, what quadrant does that put me in? The inverse tangent, when I'm taking that of a negative value, leaves me in quadrant 4. Okay, so if I land in quadrant 4, the value from the calculator was in the negative direction, but I need to return my answer in a positive direction. So I would need to basically add 360. So we're going to say 360 plus the value from my calculator, which was negative 33.69 if we rounded it to that. And that gives me a value for theta of 326.31. So algebraically, this is the form that we use. We have a formula for the magnitude as well as the inverse tangent for theta. Well, we can do this just as easily on the calculator. So to find the two components we need for my vector, remember I need the magnitude as well as the direction. We have two formulas we will use. So this is the form that we're going to use to find the magnitude. Magnitude is the length of our vector u. And in all of the things we've done so far, we have let the length of my angle, or the length of my let's say triangle, which is the hypotenuse, has always been denoted by r. So that's what this is giving me. This is going to return for me the magnitude of my vector u. And I find this by going to second, apps, which is my angle mode, And I'm going to choose option number 5. And from here, I would enter in 3, -2. Let me move that up a little. 3, -2, close the parentheses, and it returns for me the decimal value of 3.61. Now that is actually the decimal value of the square root of 13. So these are the same answers. This would be the exact answer. This would be an approximate. Now to find the direction of my vector, which would be theta, we go back to that same menu. So we're going to hit second angle. We're going to choose option number 6. And we enter in again my values of 3 and -2. So 3, -2. And you can see that it's going to return for me again that negative angle. That was the same angle we got when we took the inverse tangent, but we know that we have to then add 360 to get the positive coterminal angle of this. So that is -33.69, which is the same value I had gotten before. So you would do the same thing. And that's how we're going to go about taking, if we are given the A and B, or the horizontal and vertical components of my magnitude, of the vector, that is the process. Either solution is the process you'll go through to find both the magnitude and the direction of my vector.